is the typical piston on the head. We have the small pocket or crown, and on the side of the piston we have 3 groups. The first 2 groups are for compression rings. The first one and the second ones are compression rings. The number 3, the group number 3, is for oil controller. What is the meaning of that? The third one have a small cavities like this. Let me show. The first one and the second ones are compression rings. And the third one is the oil controller. The oil penetrates from the bottom, from the oil pan or the oil jets, and the oil passes through those small drills and return in the bottom. This is the typical picture, picture of cast aluminum. If you see the picture, there are a lot of bubbles of air. There are a lot of impurities of carbon, this is the structure is not organized. This is the structure of cast aluminum, and this is a picture of the structure of forged aluminum. If you see the structure is more organized, it's better, no impurities, no bubbles. What is the problem with the bubbles internally in the piston? We are going to talk specifically about the bubbles inside of the piston. If the structure of the piston is cast material with too much air, too much bubbles, when the temperature of the piston increase, the diameter of the bubbles increase, and it's possible that those bubbles expand cracks and propagate the cracks, and for fatigue, suddenly the piston is broken. This is the problem. The air inside of those structures expand with the temperature and propagate cracks. The oil is coming from the oil jets in the bottom. It's a jet of oil that is sprayed in the bottom and enter inside of the piston. However, inside of the piston have a small drills connected with the third group, the bottom group, and the oil circulates through the bottom of the oil to the oil pan, and once again the jets inject oil and the oil return. In other words, the function of the oil jets is introduce the oil on top and spray the oil in the bottom of the cylinder liner, and at the end of the day the oil enter here, goes over there and return. This is the path of circulation of oil. If you check this picture, we have oil until the bottom ring, piston ring. We don't have oil going up from this point and up. In other words, if you have oil in the combustion chamber, what is the symptom when you have oil in the combustion chamber? Oil entering in the combustion chamber during the explosion. What is the symptom? Yes, blue smoke. If you have blue smoke, the majority of the technicians say, oh, this is a problem with the piston rings. No. What is the symptom when you have problem with the piston rings? Yes, low compression. The most common type of alloys are for piston rings have excessive amount of chromium, molybdenum, vanadium, titanium, nickel, and copper. And if you remember on the crankshaft, we have high concentration of chromium and high concentration of molybdenum. Once again, chromium and molybdenum. Very important. Remember my recommendation, take a sample of oil and send the sample of oil to the laboratory in order to analyze the content of other metals, other minerals, other additives in the sample, and analyze what is the situation, what happened with your engine, where is located the problem, and how can you solve that problem. In this specific case, if you found it in the report of the oil sample excessive amount of chromium an excessive amount of molybdenum, you have two possibilities: the crankshaft or the piston rings. How can you identify if it's the crankshaft or if it's the piston rings? Okay, if it's the crankshaft, if I have deterioration in my crankshaft, if I have a dents on the surface of the crankshaft, on the main journals or on the rod journals, probably I have one code activated in my computer. What is the name of that code? Yeah, knock sensor. You need remove the piston ring, go into the file, put a file on the device, and sand it a little the end of the piston rings. And once again, introduce the piston ring into the cylinder, straight the piston with the face of the piston, and now once again check with your filler gauge and verify that the filler gauge recommended enter properly in the end gap. Okay, if the filler gauge enter properly, is because those piston rings are the piston rings recommended. We are going to use the tool, open and close. Be careful, open the piston ring only the space necessary to introduce. With the other finger you introduce the ring on the groove and you release the tool slowly. That's the procedure.